Hey everyone, welcome to more AP Stats. Today we're deep into regression by now, and we're going to be looking at Stats Medic Day 3 of Section 3.2, which is going to be more of that regressional analysis. So now that we know how to create regression lines, now we're looking at analyzing them. So let's go over to the next screen and see what we have. As part of a new transcript at our school, the counselors have decided to include an IQ score in addition to GPA. Will knowing the GPA help predict IQ? 5 students have requested that counselors update their transcripts for them. Adam, Bernard, Christy, Deja, and Eldon. Their IQ scores are 110, 85, 120, 95, and 105. But they have all been mixed up, and the counselors do not know which IQ score goes which students. I guess typical, right? The guidance counselors are forced to predict the IQ for each student. Gosh, I hope this doesn't happen to you. Each counselor takes a different approach. So counselor number 1 is the new guy. The new guy is so nervous about being wrong, he wants to play it safe with his predictions and minimize the error. So as a stats teacher, I'm seeing some of these things here. We're going to minimize error. He decides to find the average IQ and use it as his prediction for all 5 students. So average is no big deal. It's exactly what you've been doing since 5th grade probably. So let's get the average. So just add up all of the scores together, divide by how many scores we have. We get an average of 103. And then we just pretend, or we estimate, that everybody's IQ score is 103, which is probably nice for you if you happen to be 85 and 95, but not so nice if you're 120 or 110 or even 105. So for some people it'll work out better. For some people, not so much. Let's look at the veteran. The veteran noticed an equation written on the board of the AP Stats room. IQ equals 16. That's supposed to be at times GPA plus 57.3. She realized that GPA can help her make a better prediction. So she looks at the GPA of each student, and then she uses this line of best fit to make her predictions. So we'll go through the first one. If the GPA is 18 for Adam, that means his IQ should be approximately equal to 86.1, and we'll put our 86.1 here. And this should not be all that crazy for you at this point. This is what we do with linear regressions. We take our explanatory variable, we chuck it into the LSRL, and we output a prediction for our response variable. So let's do the rest of these real quick. And Eldon is predicted to be at 118.1. All right, so that's using lines of best fit or least square regression lines to calculate. Let's take a look at counselor number 3, the truth seeker. So the truth seeker just decided to call every student out of class and ask them the truth. So here are their actual IQs. And this is a prediction using LSRL. And that means this one over here, this is a prediction using, and I'm going to say it's Y bar, which would be the average IQ. Okay, so we have all of that. And the last, not the last part, but the next part is we're going to take all of our counselors and we're going to calculate what is going to be end up being the squared residual. So we're taking a look at the new guy here. The new guy predicted everybody had a 103 IQ. So for Adam, his IQ is 103. Well, 85 actual minus predicted is 85 minus 103. That is negative 18. And when you square that, you get 324. For Bernard, again, the predicted IQ is 103. This time, Bernard is pretty close. His actual score was 8 less than the predicted score, so negative 8 error. And negative 8 squared is 64. Let's do the rest of these. And look at that, Deja actually was really close to the prediction. She only had an error. I don't know. Deja's error between the prediction and the actual IQ is only 2 units, which gives me a square of 4. If you're new to stats, then you're saying, why are we just squaring all the error? Why can't we just take an absolute value? And of course, this is related to the standard deviation. And in the standard deviation, we square them so we can find an average distance, kind of like a Pythagorean distance. So, next step is to add everything together. You get 730 if you add them all together. And what is that number really? Well, that is the sum of all the squared errors. And you might want to think about that as an expression of how well or how poorly the prediction went when we used the mean IQ for every prediction. Let's take a look at the veteran. And we're going to do something really similar for the veteran. We're going to get the veteran's predicted IQ. See, for Adam, that was 86.1. That had an error of negative 1.1. And when you square that error of negative 1.1, you get 1.21. And we're just going to go down the list with everybody. You might have to flip back and forth between page 1 and 2. But I think that's pretty manageable. So we add all of that error, the squared error together, and we get 89.9. And look at these two numbers, how drastically different they are. 730, 89.89. That is a lot of change. Question: who did better? And why do you think that? Well, from what I can see, I mean, just taking a look at the errors, it seems like the veteran did better. And the veteran did better and why? What could we? Are there two T's in better? I think there are. Did better, and based on the numbers that we see in the blue boxes, the sum of squared errors for counselor 2 is 89.9, and it's less than the sum of squared errors for counselor number 1, who, by the way, had 730. Counselor number 1, squared errors, 730. Counselor 2, sum of squared errors, 89.89. Sum of squared errors. So, how much better is using that LSRL? Can we say what percent better that is with the sum of the squared errors? Okay. Well, percent increase or percent decrease is always going to be equal to original, which was 730, minus the new, which was 89.89. So this is the improvement divided by the original. So it's improvement improvement over original error. And the numbers I'm getting are 640.11 over 730. And when you divide that, you should get 0.877. That's an 87.7% improvement. Okay. We could also find each counselor's typical error. So we're going to use algebra to turn the sum of squared error into an average error. And that's kind of cryptic, but the idea here is, like the square root, we're going to take that, 89.89, and we're going to divide it by 5, and then we're going to square root that. And the number we get is 4.24. Okay. So this would be a typical distance between a prediction and the actual. Okay. Moving on here, we're going to find correlation, coefficient of determination, and standard deviation of the residuals for the data using our calculator. So we're going to take a minute here and we're going to go ahead and grab our calculator now. So I don't really know where everybody is in their calculator. Maybe you came to my channel not from my class but from somewhere else. But in order to get the correct regressional analysis, we need to prep our calculator for stats work. To do that, we're going to start at the home screen. I'm going to push clear a couple times because I like a clear screen. And then I'm going to push second 0, which puts me into the catalog. This is all the calculator functions your calculator knows. And we need to get to one called diagnostics. So if you push x to the -1 power, you'll see that that's below the letter D. That'll bring us to all the D commands. And we're just going to scroll until we see diagnostic on. There we go. Diagnostic on. Push enter. And push enter again to actually execute the command. And it's going to say done, which I guess is kind of cryptic, but you'll see the difference in a second. Next step here would be to go to the stat edit menu like every other one of our regressions, and we're going to put our independent variables or our explanatory variables. Sorry, I was in algebra land for a minute there. We're going to take our deep explanatory variable. We're going to put them in L1. Remember that our explanatory variable here is going to be the GPA. And we're going to put our response variable here in L2. And we're trying to show that the IQ is a response variable to the GPA. Okay. Just like every other regression we do, we're going to push second, quit. And then from the home screen, let's clear that again. I like a clear screen. You'll push stat, calculate, and then we're going to calculate a plus bx. Remember, a plus bx is the preferred way to write a linear regression in statistics. And the reason why it's that way, I don't know if you want to go into it, but it's for multivariable multi-explanatory variable regressions. You don't need to go there. That's fine. I'm going to push 8, and it's going to ask you, where did you put the list of x's? Where did you put the list of y's? Frequency list. Here in AP Stats, we don't really use a frequency list, so leave that blank. Where do you want to store the regression? And it's a good idea to start storing your regressions. Let's call it in Y1. We're probably not going to use that here, but we might. But it's good to have that just in case. So every time I make a function call to Y1, it'll be this regression line that I am calculating. Calculate. Great. So if our regression line is y equals a plus bx, then the value of a is 57.34, just like they said in the AP Stats class. The value of b is 15.96, which is close to the 16 that they were using in the AP Stats class. And then these next two numbers are the numbers that, how do I say this? These are the numbers that we came up with because we did our diagnostic on. We got an r squared of 0.876 and an r of 0.936. One thing to notice here is that this value r squared is the same value from here. R squared is that percent improvement by using a linear regression over just the average response variable. That's the main thing that we're trying to see here. I totally forgot that the calculator doesn't actually give you a value of s, which isn't really a problem. The value of s would mostly be given to you with one of those printouts that you see a lot in AP Stats. But one way to get that value of s really easy is just to go to Staplet. So I'm going to take it to Staplet right now. Here in Staplet, we're going to do where is it? There we go. Two quantitative variables. Let me go ahead and zoom in there. Two quantitative variables. And we're going to enter in our quantitative variable information here. I think this is GPA and this is IQ. What were the GPAs? They were 1.8, 2.4, 2.9, etc. And then the IQs started with 85, etc. Begin analysis, and you'll see that does look pretty linear. We calculated that correlation coefficient 936. By the way, from here, 936, that was the same thing we got from our calculator. And then we're going to go to regression models, and there's our value of s. 5.473. Let's get back to that. Now you might be nervous that you're going to be asked to calculate s and you're not going to have your Staplet available to you, but that's really not going to be a problem. Calculation of s is not really tested on. Interpretation of s, that is one of the things that you are going to be tested on. So now that we have our value of s, I'm telling you that this right here is the typical distance from a predicted value to an actual value. And then if you caught me earlier, then you're probably saying, wait, wasn't that what 4.24 was? And you're right. The distinction here is this is the 5 students are a sample of a population, which is why we're doing stats. This one right here, this is the 5 students are the population. Generally speaking, if you're doing stats, you're not looking at the entire population. You're only looking at a sample of the population. So this is the correct value of s to use. Incidentally, when you find the value of s, that's just going to be equal to these, what is this sum of the squared standard, sum of the squared errors divided by n minus 2. So in our case, that was the square root of 89.89 divided by 3. You might be asking, why are we dividing by 2? And that is, one of the ways people talk about this is, if you think about any line, all you need are 2 points to fix exactly where that line goes. So the idea here is we're dividing by n minus 2 because we don't know the 2 magic points for this line. I don't know if that's really a great way to think about it or not, but in any case, it's going to be that sum of the squared errors divided by n minus 2. Maybe you want to see that as a formula, and that's the square root of sigma y hat minus y squared divided by n minus 2. I know, that's a lot of formulas. I said at the beginning of this chapter that it's not going to get too mathy, and it's not going to get mathy. I am responsible for telling you the formula, but in reality, you're not going to need the formula. You're always going to be able to calculate S, or S will always just be given to you. So please don't freak out over that formula. Here are the 2 learning targets for this section. Learning target 1 is just what is S, and that is the standard deviation of the residuals. You'll need to know an interpretation for that. So the interpretation, remember, this is your key, your canned response anytime someone asks you to interpret S. So it is the actual response variable in context. So the actual IQ of high school students at Taft, I guess, is about, what do we get, 5.4 units away than the value predicted by the LSRL with IQ. With GPA. So the actual IQ of Taft students is typically about 5.4 units away from the value predicted by the LSRL with GPA. R squared has a really cool name. It's called the coefficient of determination. That's metal, man. The interpretation here is about R squared percent of the variation. We got 0.877, so we would say about 87.7% of the variation in the response variable in context is accounted for by an LSRL with the explanatory variable. And that's just a fancy way of saying this about the LSRL is about this percent better than just using the average. So about, I forgot the number again, about 87.7% of the variation in IQ scores is accounted for by an LSRL with GPA. And then, of course, there is a check your understanding, which you should go through. But that's really where I'm going to stop it for you today. Thanks for watching. This is a AP Stats fun. Lot of calculations that we did here right at the very end, but really we're not going to have you responsible for a lot of those calculations, but you are responsible for interpreting those calculations. So that's it. I think I'm supposed to say stuff like click the like and subscribe and all that junk. I don't know. Whatever. I'll see you next time here with more math.